Hello again. In this video, we are going to talk about the major PRs, uh, which were far and few in between, unfortunately, but they were definitely major, at least for me, uh, in the sense that they required a lot of effort and they were of value to the project itself, and the PRs helped the project move forward. So yeah, there are three PRs in particular that I would include in this category. Uh, then there are mid-sized PRs, there are small and tiny PRs, and then there are PRs which didn't really turn out or which didn't really go anywhere. So well, that happens. Uh, One of the PRs which I'm really happy about, I would say this is the highlight of this phase, is that uh, the introduction of a new namespace, which is basically a new module within the project, which contains a few functions, but these are functions which operate at the very core of Fulcro. So let me tell you a little bit of history of Fulcro. Fulcro, as I have touched upon in the previous video, Fulcro basically evolves from Ohm and Ohm Next by David Nolan. So let me open this here. It basically evolves by through Ohm and Ohm Next. Now you have to understand how ideas flow from one person and one concept to another concept. Uh, David Nolan is the guy who works as a lead developer for ClojureScript. He really does write Clojure full time. And not only that, he works with the creator of Clojure programming language and also the creator of Datomic, which is an immutable database. Let me just open Datomic. Now, what do I mean by immutable database? It means that you can, of course, add values, but it stores them. It extends the philosophy of Clojure's persistent data structures. Think about immutable.js in ClojureScript, and you would have a good idea of what persistent data structures are. So let me add that to the list here. Right. Uh, I pressed this by default, sorry. So yeah, it stores facts, and as you can see, the facts in the database are immutable, which means that instead of being a global variable which doesn't have any memory, it has memory. So you can ask it questions like, give me the exact state of the database 3 days ago, give me the exact state of the database 20 years ago, if you feed that kind of a data in, and you can then run transactional. uh, it could be used on a transactional basis. It could be used in an analytics environment. Recently they also launched a SQL interface to this using Presto, not Pesto, I'm saying Presto. Okay, so yeah, coming back to the main topic. So this has its own query language, which is not SQL, which is based on Prolog, right? Declarative programming, and that query language. What David Nolan did is that he ported that query language out of this database, and he reimagined he repurposed it, to be rather more precise. He repurposed it to the front end. Basically, think of it this way. You have a front end and you have many components in the front end. What if each component in the front end could ask only for the things that it really needs? Now, if you have been working with React for a while, then you would definitely find similarities in this idea and GraphQL and Relay. However, you have to understand that these ideas were being developed at the same time, and they were getting mixed or influencing each other a lot, and we are now talking about these ideas in retrospect. So that's just a little bit of history. Then coming back, Tony's so the last update on this Ohm Next is around 2 years ago, but most of the files are not really updated recently. But what Tony did, Tony K is the lead developer of Fulcro. What Tony did is that he forked it and then he started developing it by himself. And then later on, the community joined in as well, because these ideas are really nice and they give you good reasonability in the front end. Now, you don't have to use Clojure or Fulcro to understand or appreciate these ideas, because you can see the synergy between this and the ideas in JS world as well. There is immutable JS, there is Redux, there is now Immer as well, and then there is Xstate. So we'll get to that later. But right now, our goal is to understand what this PR actually did. So I'm just covering up the background here. So this is the database, and similar to this, Fulcro maintains its own database in the front end, which is definitely immutable, but as an addition, it is also normalized. Now think about the concepts from SQL databases. Because of the fact that our application database is normalized, it means that, and also it is immutable. It means that we get time traveling facilities for free, and we can exactly pinpoint what the user did to create a bug. Well, rather, I should say trigger a bug, not create a bug. But well, okay. So this helps in debugging application state a lot, and you see the same ideas in JavaScript world, because, as I said, these are very synergetic. Yeah. So let's continue. So what this namespace does is that it adds utility functions for that database, and everything else which builds upon this database. In Fulcro, React is basically used as a pure function which renders everything in this database. So this is the DNA of Fulcro, and this also means that I had to understand a lot of things before I was even able to make some progress. But I did not directly make progress on this PR on the main repo. Tony suggested that we sorry, Tony suggested that we start working on a fork. So this was my fork, and we started working on this, and you will see that there are not this one. This one was not very nice. This one was fuzzed. Let me open the correct one. Yeah. So in this one, we actually worked together. Initially, I did not really realize when he mentioned on Slack channel, personal messages, that he thinks that there is an opportunity for me to actually make a good contribution, and of course, I was very excited. So initially, what my understanding was that he would probably take care of the test cases, and then I would just fill in the blanks on the implementation side, which sounded well, simple and easy. I thought that's doable in a way which is fast. But yeah, give me a moment. Yeah, so I'm back. Yeah, let's continue with this. So over here, there was a lot of design design-oriented discussion for the API, because number one, once anything goes into the main project, it's very bad to change the API of the project. And Fulcro recently had its breaking changes. So all of this, the entire namespace was supposed to be added after the public launch of version 3. So we had to be extra careful about the design of the API. So let's have a look. So we had many discussions here, and I would even take notes on what I was thinking, where I might be going wrong or something. But Tony also chimed in on certain things, and I would even add stuff like we discussed on the Slack channels, just for reference. Okay. Then there was, okay, I think a better way to talk about this is to actually show you the code. So basically, I guess this is 12 or 13 functions, utility functions in the DB helper namespace. Now it's called normalized state helpers within the main source code. But anyways, so this is the code that I worked on. You will see that some of the implementations are basically pointers slash aliases to other functions in different namespaces, and we just wanted to add maybe some error handling or edge cases, but mostly the documentation was the main purpose for this. Other than that, when we talk about tree path to DB path, here exactly from this point onwards we need to understand the Fulcro application database, normalized database, which means that even though all of the data which is in your front-end application, all of the data which is coming from the APIs, REST API, Graph API, whatever, it comes in the form of a tree, right? Because it is hierarchical. uh, this person has this uh, bank account, or this bank account has certain attributes, so it is essentially a tree. But because of the fact that the front end database is normalized in Fulcro, we have to take care of certain things. Now, to help you understand this fact better, I will go back to the documentation and show you what a very important part of the toolkit when you are working with Fulcro. This is Fulcro inspect. So as I told you earlier, all of these examples, where is an example? All of these examples are live examples, which means these are Fulcro applications. And on this page, every example is a Fulcro application, which means there are around 40 something applications on the same page. So let's pick this one only. Let me just, if I change this, you will notice, if I click here, you will notice that this changed. But right now it's not really showing you the main features of a normalized database. So let's pick another example. Maybe, as I told you, this is a very big book. So let's talk about this. I think this is a very small case, but it should make things relatively clear. So think about this. Uh, if I have to, okay, this is, let's get this out of the way. This is called an ident, and this is the name of the table, and this is the ID of the entity we are looking up. So everything, this field is a collection of idents. Right now, it only points to it is only a 2-1 uh, join, and it could also be a vector of vectors. This is way too technical in terms of closure terminology. Let me simplify it. It could be a 2-1 join, or it could be a too many join, but it is not going to go, it is not going to nest more than that. And this is essentially the core fact about core realization that a normalized database provides us. So for example, if this was a bunch of, if this was, let me just write it down. So this would be a too many join, and it would mean that this table, the table name is field right now. This table has two pointers. Right now it is only showing one, but if we talk about this, it would mean it has two pointers, and each pointer is broken down in such a way that this is the table name and this is the ID of that entity. So it means go to field slash by ID, and this is the new table, and here is the entity, and then here are the attributes. So instead of having a very long chain, well, okay, let me put it this way. Instead of growing horizontally, as you might expect a tree to grow, it is definitely going to grow vertically. So This simplifies data manipulation a lot. And yeah, so this is one of the central aspects of Fulcro. And okay, I think this is enough for the background of this, uh, for all the implementation in the namespace. So let's go back to this function. This is tree path to db path, which converts basically the tree path of the tree path would be the raw path in the incoming data, and then db path would be how can you reach that same data in the normalized database. So this is, as you can read, this is this is a recursive function. So we had to take care of all the pointers it might give us and then actually point directly to that entity using the normalized database path. So this is it. I know it's a little bit confusing, but this is one of the reasons why I spent time on this Fulcro inspect tool earlier. But we don't have to get so much in deep right now, so you can feel free to contact me and the community as well. So it's great if you get in touch. Other than that, this is a wrapper for the core. Well, not a wrapper, this is a superset. Actually, you can call it a wrapper, I guess. This is a superset of a core closure utility called getIn, which basically adds the capability to this utility that it can make use of it can also work on normalized databases, specifically the Fulcro normalized database. And so we feed this function to this getIn, and we have patched the internal or original getIn function to work with Fulcro database. Then there is a relatively simple function which basically converts the UI to properties, and then there is another top level function. This is not directly related to Fulcro, but since almost everything in Clojure is about data, I think this is true for most programming languages anyway. So this is basically, if you have think of a nested JSON, and this basically takes away one part of that JSON, specifically one part of that JSON. So yeah, but now we come to the main function, which took me a lot of time and it blew my mind. And then finally, I was able to grasp how to write things in a more idiomatic way. Of course, uh, Tony helped me a lot on this one. Tony and Wilker. So yeah, let's talk a little bit about this. You will see that based on the arity of this function, on toArity, I'm just calling the same thing I have defined here in this case, but in this aspect, I have specifically hard coded the cascading option. Here is the cascade, right? So you will notice that since everything to the leftmost as part would be a top level function, pardon, and everything here would be a function local, would be inside a function scope. Basically, the top level, it does not pollute the top level namespace. So this gives me the freedom to define my own abstractions within a function itself. We do this a lot in JavaScript. So think about arrow functions, think about anonymous functions. So basically this, but was pretty much the same. However, there are slight differences. So rather than focusing on that, let's continue with the PR. This Then think of this as it takes in the data, calculates normalized paths, then calculates ident specific paths from the table, from the normalized database, and then removes an ident from one path, then builds upon this one and removes an ident from tables, then removes the ident from entities and state, and then so on and so forth. You will see actually the function body has only one thing. All of the processing for this function was already done in its let forms. So this was mind blowing to me, because the way I would have designed this without any guidance would be this part would be a function, this part would be a function, and this part would be a function, different functions. Even if I explicitly make them private function, like I made this one, but I would not have thought about thinking in terms of levels of computation within a function. So this was really nice. Uh, yeah. So when after actually working on this PR on my own fork, when I created this PR on the main repository, Tony felt that there is one function or one utility that he's not really confident about, uh, even though that even though it works perfectly fine. However, we have to be, well, I think it's not me. What I learned from him in this case is that he was very specific whether to give this name to this specific utility, because as you might be aware that one of the hardest things in programming is naming things correctly. So is the question here is whether or not this function is correct. It is correct. The question here is whether we want to give this name to this functionality. And for this specific part, it seems that Wilker was kind of okay, but Tony did not feel confident about it. So in the main source code as of now, let me show you that, or that namespace. It should be uh, with an algorithm, normalized state. So here it's still commented out because, well, it's not uh, finalized yet, I guess. Maybe a purge entity or purge edge, etc., would be a better function, but this is for Tony to decide. Anyways, we can move on. Okay, so let's move on to other functions. Sort, identify. This basically, think about Lambda if you have used that in JavaScript. So it implements a part of that within this, keeping the normalized database in mind. Then there is update caller n, etc. And then there is a macro which would work only in the closure environment, not in closure script. So yeah, so all of this was really nice, but the biggest takeaway after that remove entity star function for me was testing. You will see that uh, well, this is another uh, tough point about Fulcro is that it does not really rely on vanilla tools. It relies on custom tools. So you will see in this, yeah, in this, let me fold this one. You'll see that in this namespace, we are using a Fulcro spec library. So as you might guess, this is a library by the creators of Fulcro itself. They are consuming this testing library only for Fulcro. So this is completely different library you would have to learn only for Fulcro, given that it's a wrapper around other libraries, but it is customized for Fulcro. So, and similar to that, there are many things which are specifically customized for Fulcro. There is guardrails, which adds type annotations for closure. You will see that here. This is because of guardrails. It used to be, well, before guardrails, the project used to use Ghost Wheel, but recently Tony forked it and basically added or kept only the things that which were relevant to the project. So then there is Fulcro Inspect, Fulcro Native, Fulcro WebSockets, Fulcro Garden, everything. This is an ecosystem. So if you think that you will understand one small part of this and you will make your way through, that's probably not the way to understand Fulcro. But you are free to try different techniques, different ways. Anyways, moving on to this, what I initially did in my internal PR, I actually created up a very big, yeah, I created a global state for testing various scenarios. And after some discussion, I thought a lot about this because it had to check specific scenarios for which we wanted to achieve through the functions defined in the actual implementation. Now, one of the things or one of the biggest takeaways about this is that you have to design tests in a way which rely on just like React programming, which React programming basically you should not delegate things too much at a faraway place. Keep things close to yourself. So at least this is Fulcro programming. The way Fulcro has customized, or Fulcro is using React. So the same philosophy could be applied to this. Instead of using one global state in any testing environment, uh, we could achieve the same thing by breaking this down within singular behavior and testing only this one part. Now, the reason I did not try this, and I'm still not 100% completely sure about this, is because uh, if something breaks, I would like to know where exactly it breaks on a consistent model. Initially, in or the rest of the code base, you would just see that Tony and other contributors have often used colon A and B 2. So I had to design this uh, semantic normalized database, which could include or incorporate all of the edge cases we were testing for. And then I had to break this down into various behaviors and keep it local to the test itself. So that's a mouthful. Anyways, I got this done, and yeah, so that really made me feel happy about the contribution I could finally make to the project, because unless you really talk to the developers and participate in the community, you would have no idea what needs to be done. You could do your own things, you could customize it and keep it to yourself, but if you want your code to get in, you would have to get in touch. I think this works. So this was one of the biggest PRs which I successfully completed. Another PR I would like to talk about is this ASCII doctor. So yeah, let's keep this video short, and I'll talk about this ASCII doctor PR in the next one. Thank you for watching. See you next time.